Okay, so this is where we left off with the last video. One thing I did want to show you was that if you want to toggle between your output and your data window, you can go to Window and you can go to, you'll see it lists your SPSS data set and your output. So you can just click on that and it will take you there. Okay, so the next thing that I wanted to do was to just show you a few things that you can do with the data. So one thing that you might be interested in doing, just to get a different look at the data set, is you can go under in your page 11 of your book, if you go under data and you scroll down to sort cases, you can pick what you want it sorted by. So just for grins, I'm going to sort it by ID number. You click OK, and sorry about that. What's going to happen is now the data will be sorted numerically, ascending from lowest to highest, so that you can see that. Another thing that you might want to do, just for fun, again, go to Data, go to Sort Cases, and if you want to stop that, so you can hit Reset, and that will just put everything back into the default. Maybe we want to sort by smoker because we want to take a look at that. So we can hit OK, and what we're going to see now is that all our smokers are in one spot and all of our non-smokers are together. There's a number of reasons why you might want to do this. It's not really critical, but just something I thought you might want to see how to do. So one of the last things that I want to demonstrate for you right now, actually not last, but a couple things that I wanted to show you how to do is if you were to go to page 13, it's described as problem E. I'm going to show you how to do a two-sample t-test or an independent samples t-test. All right, so you have your data, and then if you go to page 14, step 3, because that's where we're going to start, you're going to go under Analyze. You're going to scroll down to Compare Means. A couple things you can notice here, right? Is it has means, it has the one sample t-test, that should look familiar to you, right? So that was something we learned how to do, so you can do that with SPSS. Independent samples t-test, so that's what we're going to do. Paired samples t-test, right, where you have the same group of participants tested twice, and a one-way ANOVA, another thing that we talked about. But for now, because we are comparing two independent groups, we're going to select independent samples t-test. And what we're going to look at is birth weight as the test variable. So what did I do there? I basically went under this list. This is the list of all the variables that are in the file. I selected the variable that I wanted as my dependent measure, and I slid it right over there. And now I want my independent variable, which is going to be mother smoker status, right? Because we would predict that women who are smokers are going to have lower birth weight babies than women who are non-smokers. So what I need to do then, if you'll notice here in the grouping variable, right? So test variables are dependent variable. SPSS doesn't always make things as clear as they should be. Our independent variables are grouping variable. You'll notice the two question marks. So we need to specify what values are going to be used. So essentially all we're going to do is we're going to tell them that group 1 has a value of 0 and group 2 has a value of 1. And so I put 0 next to group 1 and 1 next to group 2, and I hit continue. We can look under options, but really that's not going to give us anything that we need to worry about. So that's all I'm going to do, and I'm going to hit OK. And what's going to happen, sorry, there we go, hold on. Oh boy, sorry, SPSS is really temperamental when trying to do this. Okay, there we go, sort of. All right, hold on. There we go. There we go. So what you're going to see here is a right out of the command. So it's just saying t-test groups. Our dependent measure is smoker coded 0 and 1. And then it's going to tell us what our variable is, which is our independent variable. I'm sorry, t-test smoker groups. That's our independent variable. And then our dependent measure is birth weight. I apologize, I reversed that. Okay, so first things first, we look here. It gives us some group statistics. It's telling us that it's giving us the means for birth weight for each of the two groups, for the non-smokers and the smokers. So if you look here, we can see that the non-smoker mothers had babies with birth weights of about 7 point, oops, sorry, 7.69, and they had a standard deviation of 1.15. And then the smoker mothers had babies with a birth weight of 6.873, 8773. So roughly 6.9 pounds with a standard deviation of 1.4, right? And it also gives us the standard error of the mean. Now, I'm going to minimize this, but this essentially is just a log of all of the things that we've done and that we can find. So if we wanted to scroll around through this, say I wanted to go back up and look at the frequencies, I just can click on that and that'll allow me to do that. If I want to come down to the t-test, I just click on the t-test and it's going to bring me back down to the t-test so I can take a look at that. So one of the things that we talked about for the independent samples t-test was that the variances for the two groups, so the variance for the dependent measure for the two groups, that is, so the variance for birth weight for the smokers and the non-smokers needed to be equal because we were going to be averaging the sums of squares for the two groups in order to come up with the average standard error of the mean. And so what t-test does for us is it actually does a test to make sure that the variances for the two groups are equal. So on this hand here, you'll see, Levine's test for equality of variances. Okay, so essentially it's just testing whether the variances for the smoker and the non-smoker group are equivalent. So it gives us an F of 0.3 and a significance level. So in SPSS, significance level is actually your p-value. Because this value is greater than 0.05, what that's telling us is there's no difference between the two groups in terms of the variances for birth weight. So if there had been, SPSS actually gives us an adjusted t-score. Actually, really it does is it adjusts the degrees of freedom. But because that's not necessary, we can use the top row, which is the equal variances assumed, meaning that this suggests that both variances are equal. So we're going to now scroll over here. Sorry. And we're going to look at the actual t-test. So this is the t-test for equality of means, right? So we have the Levine's test for equality of variances, and this is our t-test for equality of means. So we're looking in the top row. We get a t-value of 2.054 with 40 degrees of freedom, right? So if you recall, the independent samples t-test has degrees of freedom of n-2 because we have two groups, right? So we had 42 participants giving us 40 degrees of freedom. And our two-tailed significance level is 0.047 or roughly 0.05. Now, because it's equal to or less than 0.05, we will reject the null hypothesis in that case. So a couple other things is this tells us what's the actual differences between the two means. So it's roughly almost a full pound difference between the smoker and non-smoker moms, and that's the standard error of the difference. And then this is our 95% confidence intervals, which we didn't talk about, so you're not going to worry about that. So essentially, because this is statistically significant, we can conclude that moms who were non-smokers had babies who weighed more at birth than moms who were smokers. All right, and I'm going to remind you again that while we looked at critical values when we were hand calculating, when we're in SPSS, we're going to look at significance, and that significance refers to your p-value, right? And the p-value is the probability that you're making a type 1 error, and we set alpha or p at 0.05, and in this case, we conclude that a result is statistically significant if our p is less than 0.05. Now, the good news here is you're not going to get any negative values, so that's not going to make things as complicated as they could otherwise be. All right. Okay, so the last thing I wanted to show you was how to run a correlation. We don't have in this particular data set, we don't have an independent variable with three groups, so I'm not going to show you one-way analysis of variance just yet. But this is sort of, like I said, your brief introduction to SPSS. So in this case, you would go to page 15 and look at problem F. And in particular, the instructions for running a correlation are actually on page 16. So what you're going to do is you're going to click on Analyze. Again, you would start at step 5 since the file's already open. And in this case, you're going to scroll down to Correlate. All right, and because we're looking at two variables, so we're going to look at the association between birth weight and mother's age. Because why not? Because we can. So we're interested in a bivariate correlation, and this was the Pearson R that I talked about in the previous lecture. And so when we click on that, a little window or box is going to pop up. So the next thing we do is this here is all of the variables in our data set. So we're looking at birth weight and we're looking at mother's age. Oh, and if we wanted to, we can actually add in a couple others. So let's just say gestation is going to go in there. We can look at mother's height, and how about, just for grins, father's age and father's height. So notice that there's no independent or dependent variable specified here. And the reason for that is because these are correlations, right? So we're not predicting a direction of the effect. If we were, we could request a one-tailed significance test, but in this case, I mean, I do have certain predictions I could make about that, but I'm not going to. And we need to make sure that flag significant correlations is clicked, because that's going to tell us which of the correlations between which variables are statistically significant or not. So we don't even have to interpret p-values. We simply look at it and it's going to show asterisks next to those correlations that are statistically significant. Options, if you want, you can get means and standard deviations. I'm not going to recommend that right now. And we're just going to click OK. And once again, my output's going to look funky because it likes to waste time. There we go. All right, so what it provides for us here is this nice little correlation table. All of the variables that we included in here are along the top here. And then again, they're also listed along the side, right? So you'll notice down here, this diagonal here with correlation of 1, that's because it is the variable correlated with itself. So really you only need to look at the bottom half or the top half depending on your preference. So if we look here, you'll notice that in some cases we have correlations that have 2 asterisks or 1 asterisk, and you'll note here that a correlation that's designated with 2 asterisks is significant at the 0.01 level of two-tailed significance, and a correlation here with a 1 asterisk is significant at the 0.05 level. But it also gives you the p-value, so you could specify it yourself, but this makes it easier. So what this one says is that weeks of gestation, so how long the mom gestated for before she gave birth, is positively associated with birth weight, right? So we get a significant positive association between those two variables. We have a positive association between mother's height and birth weight, right? So in this case here with gestation, what we find is that the longer the mother was gestating for, right? So the closer to 40 weeks, the heavier the baby was. That's fairly typical. Here we have maternal height, again, a significant, but at 0.05, statistically significant finding. In this case, what it tells us is that there's a positive association between mother's height and baby's birth weight. So taller mothers had heavier babies. Okay, nothing else statistically significant with birth weight. We saw a positive correlation, probably nothing we're all that concerned about, between parents' age, right? So as fathers were older, mothers were also older, and no other effect was statistically significant. So father's height did not affect birth weight. Father's age did not affect birth weight. Mother's age did not affect the baby's birth weight. The only things that seemed to affect it were the length of the gestation, so how long the baby cooked for,